Have you ever wondered if time travel is possible? Perhaps you've read the book The Time Machine, or you've seen the movie Terminator. Both stories explore the paradoxes of time travel and the manipulation of space-time. While these stories are fictional, they provide fuel for the imagination to consider time travel as possible. In fact, there are no known laws of physics that prevent time travel. Albert Einstein's work on the theories of general and special relativity laid the foundation for the reality of time travel. His postulates opened the theoretical door for physicists to realize time travel as possible. We will examine the first type of time travel to be discovered. It is known as time dilation and occurs in two ways, by mass and motion. We will examine time travel by means of Einstein's theories. Time travel is theoretically possible. Who knows what the future may hold? Most everyone has heard of Einstein's famous equation that so simply states the law of relativity. E equals mc squared, or energy equals mass times the speed of light squared. Einstein discovered that space and time are actually interwoven like a fabric, hence the term space-time. He then realized that the only constant in the universe is the speed of light, meaning it never changes no matter the context or circumstance. Light always travels at 186,000 miles per second. It is the universal speed limit. Nothing can exceed it. Since space and time are interdependent, this gives cause for time dilation to occur. Time dilation is simply the slowing of time in one frame of reference compared to another. This was, is, and will continue to happen throughout the universe. It even happens here on Earth every day. The clock hanging on your wall at home actually ticks slower than the watch on your wrist when you're driving in your car. However, the dilation is so minute that it is not measurable by any skills of calibration that we possess. But thanks to special relativity, we know it's a reality. One way time dilation occurs is by mass. The larger or more mass an object, say for instance a planet, has, the slower time passes there relative to another planet of less mass. For instance, if I were on Jupiter and you were on Earth, time would move slower for me in relation to you. A more intriguing way to time dilation occurs is by motion, like the clock and watch example. The faster an object moves through space, the slower time passes for that object relative to the surrounding universe. This is the effect of time dilation by motion. There is a thought experiment known as the twin paradox that starkly contrasts the effects of time dilation by motion. It goes something like this. Say thousands of years in the future, technology has advanced to the point where spacecraft can travel at near light speed. In this future, there are a pair of twins named Isaac and Albert. Isaac is an engineer and he works on the spacecraft, while Albert is an astronaut and he pilots the spacecraft. They are both 31 years of age. Albert leaves on an expedition, traveling at near light speed for 5 years distance from the Earth. He then turns around and travels that distance back to Earth, making his total time of travel at near light speed 10 years. When Albert arrives on Earth, he discovers that his brother is now an old man of 81 years of age. 50 years have passed on Earth relative to the 10 years that passed while Albert was traveling at near light speed. Time almost stopped for Albert, yet remained unchanged for Isaac, proving by special relativity time travel is possible. I hope these definitions and examples of time dilation have enabled you to see how time travel is a reality. Who knows what type of time travel may be achieved in the future, or has it already happened?